Thanks for joining me in today's lesson. In this first tutorial, we will factor using the special patterns for squares. So here we are looking at all of our special patterns today, and we're going to be focusing on the square pattern first. You can only factor the difference of two perfect squares. That is our special pattern for squares. First of all, your eyes should be noticing that this is a binomial. And whenever there's a binomial involved, it is going to be some sort of special pattern. This is a difference because there's a minus sign, and there's two things, and each one of those things is a perfect square. So this is a difference of two perfect squares. That pattern is really simple to memorize. We're going to split apart the first term into its perfect square. A times A makes A squared. We're going to split apart the last term into its perfect squares. B times B is B squared. We're going to write our two sets of parentheses. The perfect square from the first goes in the front, A and A. The perfect square from the back goes in the back, B and B. One factor will have a positive sign, the other factor will have a minus sign. Finished. That is the difference of two perfect squares pattern. It's really simple. You split apart the perfect squares, you put them in the front. You split apart the perfect squares, you put them in the back. One's positive, one's minus, one's negative. Now, why is this true? Well, if you looked at it as the entire trinomial, you have a squared plus 0ab minus b squared. Here's your a squared minus b squared. There is no middle term over here, so it must be a 0. And there's two things that we can now notice now that we have a trinomial, and we've been factoring trinomials for a little bit now. Since this is a minus sign, that tells us that our factors have alternating signs, different signs. So that's why one's positive, one's negative. Since this middle term is missing, it's a 0, we know that they have to cancel out. These inner and outer terms have to be exact opposites. The inner terms here are a times b. The outer terms are negative a times b. And those would cancel out to 0. That's why it works. Only the difference of two perfect squares. You cannot factor a sum of two perfect squares. This is a binomial, so there must be some sort of special thing going on, but this is not a difference of two perfect squares. Because of this plus sign, this is actually prime. It is the first expression that we've seen that we cannot factor. And something that does not factor is called prime, sort of like the number 19. 19 is a prime number because it has no factors other than 1 times itself. This is a prime number. This is a prime expression. A sum of two perfect squares cannot factor. Now you might say, well, because there's a plus sign, maybe I just try two factors that have the same signs. And that's a logical thought. Let me show you over here why that is simply not true. If you just try to factor using the same signs, yes, you'll get your a squared, and you'll get your b squared. But look on the inner terms and the outer terms. The inner terms will be ab. The outer terms will be another ab. What does that add up to? Well, they don't cancel away. You have two of them. Two ab's. But there aren't two ab's here in the middle, so this is not the correct way to factor it. So maybe you say, well, if it's not two plus signs, maybe I put in two minus signs. But that won't work either because then you'd have a negative 2ab. There cannot be factors for a sum of two perfect squares. We call it prime. Okay, so let's look at two examples. 4x squared minus 121y squared. The first thing I note is that this is a binomial, so it has to be some sort of special pattern. I see that it is a difference, and it's two things, and each one of these things is a perfect square. 2 squared, x squared, 11 squared, y squared. So I know that I can factor this using my pattern right up here. I'm going to split apart 4x squared into 2x times 2x, the square roots. I'm going to take the square root of this, and that's 11y times 11y. I'm going to draw my two sets of parentheses. The 2x will go in the front. The 11y will go in the back. One will be positive, one will be negative. And I'm finished. That's your difference of two perfect squares. Let's look at the second one. This is a very interesting problem. Again, it's a binomial. Alarms going off in my brain. I know that there's a special pattern going on. This is a difference, and these are both perfect squares. X to the eighth is a perfect square because I can divide it into two factors that are identical. X to the fourth times x to the fourth. Basically, I'm cutting my exponent in half. 256 is a perfect square because I can divide that into two factors that are identical. 16 times 16. So I can factor this difference of two perfect squares using our pattern right here. X to the fourth will go on the front. 16 will go on the back. One's positive, one's negative. I'm showing you this problem because we're actually not finished. Now I see this first set of parentheses. This is a sum of two perfect squares, and a sum of two perfect squares cannot factor. So we are finished with this, but look at this second set of parentheses. This is a difference of two perfect squares. X to the fourth is a perfect square because it's x squared times x squared. 16 is a perfect square because it's 4 times 4. So I can factor this more. Now this first set of parentheses, of course, we can't do anything with, so it's just going to remain in our answer, x to the fourth plus 16. Don't forget about that, of course. But the second set of parentheses can factor again using our difference of two perfect squares pattern. X squared goes in the front, 4 goes in the back, one's positive, one's negative. Guess what? There is still more to do. Isn't this fun? We can't do anything with this. We cannot factor a sum of two perfect squares. We cannot do anything with this. It's a sum of two perfect squares. But look at this one. Another difference of two perfect squares. This is x times x, and this is 2 times 2. So I can factor this again. Now the first two sets of parentheses, of course, will just remain. X to the fourth plus 16, x squared plus 4. But this last set will factor one more time. X and x go in the front, 2 and 2 go in the back. One's positive, one's negative. This is not a difference of two perfect squares, so we are finished. That is a pretty cool problem. Thanks for watching this quick tutorial on the difference of two perfect squares. See you in class.